email, and I graduated from Rose-Hulman with a degree in computer engineering. When I was an incoming freshman, I didn't know anything about computer engineering. All I knew was that it had something to do with computers, and it was a combination of electrical engineering and computer science. In that sense, I got the best of both worlds. However, computer engineers shine in a few areas that might be difficult for either an electrical engineer or a computer scientist. These areas include embedded systems, computer architecture, and digital signal processing. But what kind of jobs would it prepare you for? Well, you could design consumer electronics, such as smartphones, smartwatches, e-book readers, or maybe the next generation of Intel CPUs. Many new medical devices and scanners rely on electronics designed by computer engineers. The Department of Defense and various contractors need computer engineers to create unmanned aerial vehicle flight controls and crucial satellite communication systems. In aerospace, you might work on an autopilot for the next Boeing plane or create the control system for the next Mars rover. Finally, in the world of automation, computer engineers are writing low-level software for Amazon's warehouse robots that help pick and deliver goods for packaging. So, what kind of classes will you take to become a computer engineer? First, you'll need a healthy dose of math. Particularly, you'll need calculus, differential equations, and some probability theory. From the computer science side, you will likely learn a couple of programming languages. These languages allow you to write code to tell computers what to do. You might start with a low-level programming language, like C, to teach you the underlying concepts of how an operating system works. You might practice what you learn with a project, such as writing a device driver for your computer to, say, respond to mouse clicks, or read from a USB drive. You will also learn a high-level programming language, such as Java or Python. These are application-level languages that teach you higher-level computer science concepts, such as object-oriented programming and algorithm design. Projects might include writing a smartphone app, creating a simple game like Flappy Bird, or searching through a database for customer information. You will be introduced to a variety of algorithms, which is just a fancy way of saying steps required to solve a problem. Google, for example, uses a very complicated algorithm to crawl through the internet and sort your search results, starting with the most relevant. You will learn how to develop algorithms like this and analyze them for execution time and efficiency. From the electrical engineering side, you will usually start with basic circuit design, which includes creating and analyzing simple circuits with passive components like resistors, inductors, and capacitors. Labs might include designing circuits on paper, building them on a breadboard, and then testing their operation with an oscilloscope. Later classes will introduce semiconductor components like diodes and transistors. These lay the foundation for courses in digital circuit design, including logic gate operation, Boolean algebra, and binary. These classes will lead into computer architecture, where you will learn how a computer works, like really works. Often, you will be required to design your own computer processing unit, or CPU, by the end of the class. With these foundations, you can then move into the more specialized areas of computer engineering, and this is where the fun begins. You will likely take a class in embedded systems, which are essentially tiny, chip-sized computers with processors known as microcontrollers. Knowing the basics of electronics and low-level programming allow you to work with microcontrollers, which can be found in smartwatches, drones, and modern thermostats. If you have heard of Arduino, it is a type of embedded system. Finally, you'll be required to take at least one class in signal processing, which is the analysis of how electrical signals change over time. Here, you will be introduced to communication systems and filters. Trying to transmit data over long distances, say images of Mars from the Curiosity rover, requires a lot of engineering, and signal processing is just the beginning of these types of communication systems. Computer engineering also puts you in a good place to study robotics, as most robots rely on embedded systems for their brains. And these are just some of the things that computer engineering lets you do. It gives you a taste for electronics as well as programming, but it also allows you to specialize in some fields that develop exciting new technologies that affect our everyday lives.